all repeat. So this one, you can't just stick 2 9s underneath it because there are not, like, this number repeats, but that number does not. So that throws a wrinkle into, like, how you can't use the shortcut for converting a repeating decimal into a fraction. I don't know who the person is that figured out that this strategy works, like how their mind must work. Like, it's kind of beyond me. Like, I don't know if it's genius or crazy, but this strategy does work. And, honestly, at this point, kind of genius. And I know it was a lot of steps. We walked through an example yesterday where and I know yesterday we went through a couple of these, but after some reflection, because each individual step on its own really isn't that challenging, but it's tedious and there's a lot of little steps where you can make mistakes. So I thought it might be helpful to kind of break it down into steps. And First Block told me, oh yeah, I made a big difference today. It helped them to click a lot better by breaking it up just a little bit. So we're looking at the decimal, 0.9 with a 1 that is repeating. So as you fill in the class kick, obviously, my boxes won't turn green, but yours will as you go through and plug in the answers. So looking at my little chart that we looked at yesterday, remember it says that if 1 digit repeats, you multiply by 10. Actually, let me back up for a second. First thing you're always going to want to do is start off with a basic equation where you set x equal to whatever the repeating decimal is. Now, I happen to put 3 1s with little dots going after it. I just as easily could have put 2 1s or 5 1s. It really doesn't matter because it's an infinite number of 1s, but I just chose 3 because it made most sense to me to show you the concept I'm getting ready to show you without overdoing it. So it doesn't matter how many repeating decimal digits you put in your original equation when you set the x equal to the decimal, okay? So now we need to set up our second equation. And again, I'm going to go over to the little notes example that I gave you yesterday where it says, so how do I decide? If it repeats 1 digit, we're going to multiply by 10. Well, that fits the bill. This is the one we're going to use because there is, in fact, 1 repeating digit, and that repeating digit is a 1. So I'm going to fill in this box with there is 1 digit repeating. So that means we need to multiply by 10. So when I go to set up my other equation on top of the original decimal, I'm going to multiply x by 10. Now, what does that mean for the decimal? Since I multiplied the x of the equation by 10, I also have to multiply the right side of the equation by 10. And you guys know, which is awesome, Miss V really killed it with you guys last year, if you multiply a decimal by 10, what's going to happen to the decimal? It's going to move over 1 spot, right? So your new equation that goes on top of the old equation is going to be not 0.9, but 9 point, because that decimal is going to move over 1 place. I can't stress enough how important it is when you set these equations up that you keep them nice and lined up, that those decimals are lined up right on top of each other, because decimal alignment matters, and we're getting ready to do some subtraction. So instead of 0.9, this is going to be 9.1111, and technically, that is repeating forever and ever and ever. Now, what was the point of getting a version of that decimal that has the decimal moved over 1 place? We can't use the shortcut, but we can't also just be like, hey, 1 over the denominator, because that 1 keeps repeating infinitely. So basically what we need to do, friends, is we need to get rid of that 1 that is going repeatedly forever and ever and ever. And we are going to accomplish that by using subtraction. What happens if I have an infinite number of 1s and then I take away that infinite number of 1s? How many infinite ones do I have? I don't have any left, exactly. So, my infinite number of ones lined up over my infinite number of ones, they're just going to cancel each other out because I'm going to use subtraction in order to make that happen. So each of those ones has effectively vanished because I created an equation, and you are allowed to subtract one equation from another equation. We're actually going to do that a lot at a later date. So let me finish subtracting because those yellow ones have now canceled each other out. So what I have left to subtract, I still need to do 9.1 because I still have 9.1 left minus 0.9. So I can't subtract 1. Well, actually, I can subtract 1, take away 9. But what do I actually need to do? I need to borrow, turn that into an 8, turn that into an 11. So 11 take away 9 is 2. And then 8 minus what's effectively a 0 there is an 8. When you subtract your decimals, you line them straight up. So after subtracting an infinite number of ones from the other infinite number of ones, and then just subtracting what's left over of the decimal. I know if you type this into the answer box, it's not turning green yet. I know that's probably bugging you guys. So I'll show you the rest we need to put in there in a second. Okay? So you've got to build yourself an equation with a decimal that has been multiplied by a power of 10 equal to however many decimals repeat. Okay, and what did that just allow us to do? We got to chop off, by using subtraction, all those repeating ones, and now we've just got 8.2. Now, the way equations work, if we subtract this side, we also have to subtract the left-hand side as well. So if I had 10 x's and I take away one of them, how many x's do I have left on the left-hand side? 9x. So the equation, after we combine those two equations, should be 9x is equal to 8.2. And class kick for the formatting, make sure leave a little space right there on either side of the equal sign, and it should turn up fine as far as green. So there should be, I tried to make sure it stayed a little bit lined up for you. So if you don't have the spacing quite right, it's not going to work. So make sure you've got a space on either side of that equal sign. So now we finally got something we can turn into a fraction, because we know that to cancel out that 9, what is going to be the inverse of that 9? How are we going to cancel it out? We're going to divide, and it just so happens that division is a fraction. Okay? So now we've got the equation. X is equal to, well, what is the fraction without us having simplified or done anything yet? It's going to be 8.2 over 9. So if you type, don't type the x equals, because I just want the fraction. The whole point of us going through this is to get it as a fraction. So if you got 8.2 over 9, that turned green, correct? Yes. You typed it in there? Okay. Now, it specifically asks for a simplified fraction. You can't have a decimal in a fully simplified fraction, okay? So, but that's okay, because we know the way that we can get that 8.2 to not be a decimal anymore is to multiply it by 10, because what will happen when I multiply it by 10? It'll move that decimal point over one place to the right. But if I multiply the numerator by 10, what do I have to do to the denominator? Multiply that by 10 also. So our new version of the fraction with no decimal in it now is 82 over 90. Woo! And last but not least, simplify if possible. Well, 82 and 90 are even numbers, so I know I can at least divide them by 2. 82 divided by 2 is 41. 90 divided by 2 is 45. That is as simple as it's going to get. Okay, to fill in the first couple of boxes. Oh, I know it's kind of hard to see on my version. Hopefully your copy is a little bit better. There's a line over the 3. So it's the 3 that's repeating. Hopefully yours looks a little bit better than mine. So I'm going to give you a second to try to set up the first steps, where you figure out what that second equation would be. Make sure you line them up nice and neatly. But I'm going to give you the answer in just a second. All right, so how many decimals repeat, mathematicians? 1, because there's a 3 repeating. So 1 digit, according to our chart, to set up our new equation, 1 digit repeats, so we need to multiply the equation by 10. So I've already set up the original equation for you. So you just need to set up 10x. And what's that 10 going to do? It's going to move the decimal point over 1 place to the right. So instead of 3.8, you're going to have 38 point, and then 3 repeating. So you know that you're on the right track because you have all those 3s that repeat sitting on top of each other that are getting ready to do what? They're getting ready to go bye-bye. Okay? Since we've got all this infinite number of 3s on top of each other in the equation on the same side of the equal sign, we're just going to subtract them off. So the only subtraction you have left to do is right here. So we've effectively chopped off that repetitive part so that now we can just subtract what's left over. So I know you guys know this part. Miss V is real great. I know you got to borrow. So that's going to leave me with a 5. Remember, decimal subtraction, you line it up straight down. So if I haven't made some goofy mistake, which is possible, but I don't think so. So we should have 34.5, right? Thanks. And then once again, we had 10 x's. We're going to take away one of them because if we subtracted the right-hand side, we've got to subtract the left-hand side. So we've got 9 x's is equal to 34.5. That should turn green as long as you mind your spacing on either side of the equal sign right there. Yes, dear. Always a 9. If you have to move the decimal point over 2 places, like you'll have to do on the next page, what do you think it might be? Since you have to multiply both sides by 100 instead. It'll be 99. Yeah, exactly. So are 9s heavily involved? Yes. Because you're always going to be taking a power of 10 and taking away 1. That's a really great question, honey. So it'll always be like 9x or 99x or 999x. 999, if you have to multiply both sides by 1,000, a lot of the time that means you got to simplify a really big number. So I'm not going to give you any of those. I think that's doing too much. That's being way too extra. It's enough that y'all are having to do this. So after this step, we know what to do, right? We're going to divide both sides by 9, which will give us our fraction of 34.5 over 9. But we know that we can't leave a simplified fraction with that decimal in it. So we're going to multiply the numerator and the denominator by 10. So that gets us 345 over 90. And then don't do what I did last night and forget to simplify it all the way. The first thing I noticed, I noticed right away that they're both divisible by 5 because this one ends in a 5 and that one ends in a 0. And I didn't finish it out all the way. You can actually divide them by, and if you have to divide them in 2 steps, there's nothing wrong with that. But you can divide it by 5 and then you can divide it by 3. Actually, or you can just divide it by 15 in the first place. So your simplified version will be, somebody help me out, remember what it was. What is it? Thank you, 23 over 6, yeah. So there's 3 different places for the fraction, yeah. That's the other part, yeah. So The mistake that I definitely saw first period or first block making the most was lining up the decimals correctly. If you don't line them upright to start, that really kind of, when you subtract, a lot of the time you do your subtraction wrong. And then when you go to page 3, you have 2 repeating decimals this time instead of 1. So what are you about to do instead of multiplying both sides by 10? You're getting ready to multiply both sides by 100. Exactly.